Hello all, welcome to part 2 of today's lecture on polar graphs. Our last shape that we're going to talk about is rose curves, so probably not as familiar as lines and circles are. This graph right here is an example of a rose curve. So a rose curve is when you have a function or an equation that is r is equal to a cosine of n theta, or r is equal to a times sine of n theta. So the difference between these and circles is that you have that n in there, where n is an integer greater than 1. So for rose curves, this flowchart is your best friend. I know it looks like it's a lot. I promise it's not that bad. So let's walk through it with this graph right up here. So with this graph, first thing that we want to see, if n is odd, there are n petals, and if n is even, there are 2 n petals. So in this case, we have 8 petals, so that means that n is equal to 4, because that would give us 2 times 4 would give us 8 petals. So we've established that. Next thing to do is see if we have cosine or sine. If you have a cosine function, the first petal is going to be at 0 degrees, so it will be on the x-axis. So they're talking about the tip of the petal right here. However, if r is equal to a times sine of n theta, then the first petal is at 90 divided by n. So in this case, we know that n is 4. We see that there isn't a petal on the x-axis, so that means that it's a sine function. And the first petal occurs at 90 divided by 4, which is, I want to say 22.5. Seems right. Sure. All right. So now we've established that. A is the length of each petal. So in this case, it doesn't give us an A value. It looks like it's probably about 3. I'm not sure. And then the distance between the petals is 360 divided by the number of petals. So in this case, the distance between the petals is 360 divided by 8, which gives us 45 degrees. So each petal is 45 degrees apart. So let's try some examples of this. So our first one right here, r is equal to 6 times sine of 2 theta. So first thing that we want to do is find our n value. So n is equal to 2. Going up to our flowchart, we see n is even, then there are 2 times n petals. So that means that there are 2 times 2 petals, so 4 petals. All right, next thing. This is a sine function, so the first petal is at 90 divided by n. So since this is sine, first petal at 90 divided by our n value of 2, which gives us 45 degrees. Now, A is the length of each petal. So here, this right here, we're saying that this is going to be our 30, 45, 60. These graphs are a little bit strange. The one that's on your worksheet is more like the one that you're used to, where it just has the 30, 45, and 60 in there. So we know that our first petal occurs on this line, and it is at 1, 2, 3, 4, 5, 6, right here. So that's your first petal. And then the distance between each petal is 360 divided by the number of petals. So 360 divided by 4 is equal to 45. Or no, I'm sorry, that's equal to 90. Equal to 90. There we go. So that means that each petal is 90 degrees apart. So we're at 45 here, and that means that we're going to be at our next petal is going to be at our 45 degree reference angle in quadrant 2. Our next petal is going to be at our 45 degree reference angle in quadrant 3. And then our last petal is going to be at our 45-degree reference angle in quadrant 4. So they always start from the center, and then we just kind of draw loops like this. I think making this answer key was the most soothing thing I've ever done for your class. So I thoroughly enjoyed making it. I hope you guys enjoy actually drawing these. I'm having a lot of fun. So this is your graph for r is equal to 6 times sine of 2 theta. So moving on to our next equation, we will do a cosine. So for this one, n is equal to 3. So that means there are 3 petals. It's a cosine function. So your first petal is at 0 degrees. Your a value is 7, so the length of your petal is 7. So we count out 1, 2, 3, 4, 5, 6, 7. And then the distance between your petals is 360 divided by 3, which is 120 degrees. So our next petal, since we're starting at 0, is going to be at 120 degrees. And then our last petal is going to be at 240 degrees. So that one would be right here. Yeah. And then same thing, just kind of draw the loops like this. And there you are. So last example that we will do together. Let's do this in green. Oh, I'm going to run out of room. All right. So for this one, n is equal to 4. So that means that we will have 2 times 4 petals. So 8 petals. Next, this is cosine. So we start at the x-axis, so first petal at 0 degrees. The length of our petals is 5. And then to find how far apart they are from each other, we take 360 and we divide that by 8 because that's the number of petals. And those are going to be 45 degrees apart. So they will be on our 45-degree reference angles as well as our major axes, because those are all 45 degrees apart from each other. So I've got this kind of little ugly sketch right there. All right, so now we need to count out 5. So 1, 2, 3, 4, 5. And then we go 45 degrees from there. Gives us our second petal. 45 degrees from there is our third petal. 45 degrees from there is our fourth petal. Fifth petal. Sixth petal. Nope, that's not the right one. That's going to bother me. It's this one. Sixth petal. Seventh petal. Eighth petal. This actually little ugly thing in the middle was pretty helpful. I'm not going to lie. You might want to do that. And now we just loop them together. I'm drawing at a weird angle, so this doesn't look great. I'm sorry. I would highly recommend, too, I'm putting up an answer key, but I would also recommend checking your answers in Desmos. I showed you guys on the last video how to switch Desmos into your polar grid view. So you can get it set up so it looks something like this. And then you just have to type in r equals, and then 6 sine of 2, and then I usually just type theta, and it will give you polar graphs, so you can check and make sure that your graphs look correct. That is it for today. Let me know if you have questions as you're working through the homework.